Okay, guys, so today I'm going to exam 3 review. Some of it might be repeat from class, but I just wanted to make sure that anyone who wanted to watch it completely can. And I'll try to make sure to find where the 4 hard problems start at. So in case you want to skip directly to there, you can do that. So again, what I want you guys to take away from this one is your matching. So when you have a cubed, 2 cubes adding, that is the sum of cubes. Then we also have the difference of cubes. Remember, if you have your calculator, you can check to see if a problem has cubes by doing, if you don't know how to use the cubed root, which would look like this, and then you put whatever number inside of it. The other option is to do the number and then the caret, and then 1 over whatever root you want. Okay, and that's how you find those out. So same thing can be used for square root. This is a difference of squares. This is perfect square trinomial. And of course, the one with 4 terms is the factoring by grouping. Okay, I would recommend either doing this one first or this one, either one. These, just so you know, I've told you up here, they are very similar to questions 23 through 25. And again, you're only going to have 3 matching. You won't use any term more than once. It will be one type to one kind, and that's it. Okay. Let's practice our foiling. So remember, you want to do first, outer, inner, and last. So that would be 4x times x plus 4x times 10 minus 8 times x plus 10 times negative 8. So we simplify it, 4x squared plus 40x, minus 8x minus 80. And then we want to simplify here. So we'll have 4x squared plus 32x minus 80. And that matches. So we're good to go. Okay. After this, I would probably go to the questions regarding solving. Okay, this would be again, this is the order that I would take my test in if I were to take this test. So you just want to set everything equal to 0. Each term equal to 0. So we would have 11b plus 8 equal to 0, and 30b minus 5 equal to 0. We're going to add 5. Nope, not 30. That's just a 3. So we 3b equals 5 divided by 3 divided by 3. So we could have b equals 5/3. Or the other option is we could have b equal to negative 8/11. So that's going to be in your set like this. Again, I don't care which way you want to show it. The set is obviously the best option, but again, up to you. Whatever you can remember will be fine. 16, we're just going to do c plus 5 equal to 0, c minus 12 equal to 0. We'll subtract 5, we'll add 12. So we have C is equal to -5 or +12. And if you wanted to check it, you just plug it back in. So since this one's super, super easy, let's check it. So if we plug -5 in for C, this one doesn't matter because this becomes 0, and anything times 0 is 0. So 0 equals 0. So it's true. So that first one checks. The same would work for the other option. Now, this one's a little bit different because we want to factor out a GCF, which is 7x. So greatest common factor equal to 7x. What we have left is x plus 2. And we're going to set both equal to 0. So we'll have 7x equals 0 divided by 7. We have x equal to 0 as an option. We will also have, sorry, I think I'll do that until the end of time. So -2, 0 in our set. Again, doesn't matter. Okay, so now at this point, kind of up to you where you want to go. We can start at the beginning now. Okay. And tomorrow in class, if you come at the beginning and you're like, hey, I would like to take the test the way you suggested, could we have maybe the numbers on the board or something? I don't mind doing that. Okay, so GCF for this one. A 3 and a W is present for everyone. So we're going to pull a 3W out and we'll have 5x minus 4y minus 3z. Okay, we can't do anything else with our inside factor, so we are done. And that's it for that one. Now, the next one's important. You need to see that you have both parenthesis sets are the same. So you're gonna, that's your GCF then, because you have them in both spots. Oops. So then you would write it just once and bring the outside two together. Okay. All right. And then I do want to point out for these two, for question 3 and question 5, you can rearrange if that helps you. Range. To see GCFs better. I'm going to rearrange this one. I'm not going to rearrange the other one. So this will be m squared s minus m squared t. I'm going to do a plus and then the minus inside with the as. I'm going to pull out the m squared, so I get s minus t left. And then I'm going to pull out the a, negative a. So again, I get s minus t. So I'll have m squared minus a and s minus t. And then question 4 is really unique. I was trying to get a little bit easier questions for you guys so that you could have it's kind of like the gimme points. Hopefully you'll feel that way. So here what we want to do is multiply to try and get back to where we were at the beginning of 3. So first, outer, inner, last. So we have m squared s minus m squared t minus as plus at, because negative negative is positive. That matches with what we had here. It matches, so then it double checks. All right. You don't have to show your matching or show your checks for each question, but I mean, I would really recommend doing that, because it's the only test you're really going to be able to know how well you've done when you leave. Pretty cool. So I am going to rearrange this. I'm going to do 6r squared minus 2xr and then plus 27ry minus 9xy. The reason why I'm doing this is because, number one, it gets rid of that negative being in the middle, and number two, I think it's easier for students to see 6 and 2 having a GCF than it is to see 6 and 27, but that's just me. So we are going to pull out a 2r. I'm going to have 3r minus x left, and then we'll pull out a 9, a 9y. So again, that'll leave us with a 3r minus x. So bring our outsides together. And the matching once. If you wanted to check that, you would get right back here. Okay. All right, so the question came up in one of the classes: why can't we use this as a perfect square trinomial? Here's what the pattern needs to be: r squared plus or minus 2xy plus, I guess plus or minus, whatever the other number is squared. Okay, what happens here is when we take the square root of r, we get r. Okay, so r squared, square root of r squared is r. And then we have c here, which is 36. Square root of 36 is 6. Okay, but the middle needs to be 2xy. And we need to know, do we have that? Well, the 2 is part of the formula. We have an r and we have a 6. So that would give us 12r, and we have 5r. So we can't use it. What we can do, though, is solve this like normal. So we're going to get the factors of 36, because 1 times 36 is 36. The 1's coming from the front, just like we would with problems where we don't have a 1 in front. So that would be 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. We actually want to use 4 and 9. We're going to do a negative 4r and a positive 9r. And go straight into our factoring. So r minus 4. And then we're going to bring a 9 out. Well, r minus 4 again. Bring them together, we get r plus 9 and r minus 4. Again, you could work it out to check it, but we don't have to. Now, for the next one, it's again up to you. I'm going to go through and make sure that I can FOIL back to get your answer. But if you can remember to take out a GCF, you should. And that GCF for this case is going to be -1. So we would have x squared plus 2x minus 24. Again, we're going to look at 1 times 24. So that'll give us 24, and we want factors of 24 that add or subtract to give us 2. That's going to be 4 and 6. So x squared plus, let's do the minus first. Minus 4x plus 6x minus 24. Okay. So we'll have x minus 4. And we'll pull out a 6 and we'll have x minus 4. So we have negative out front. We have x minus 4. And we have x plus 6. Okay. Again, if you wanted to check yourself, you would be correct with that. Okay. That covers us up to from 1 to 7. We've also done 22, 23, 24, 25, and we've done, let's see, 15, 16, and 17. Okay, so probably half the test. All right, so let's look at this one. We can pull out nothing. Okay, but we could do the check. So the square root of 9y squared is 3y. The square root of 4 is 2. And we have to check 2 times xy. So that would be 2 times 3y times 2. 2 times 2 is 4. 4 times 3 is 12. So we get 12y, and that does equal 12y. So we do have a perfect square trinomial. So we could go straight to this setup. We put in our x, which is 3y. We put in our y, which is 2. And then we use the same sign as our middle term, so plus. If you don't like that, you can do it the regular way for this problem. So 9 times 4 gives us 36. We need factors of 36 that will add or subtract to give us 12. And that happens to be 6 and 6. So we have 9y squared plus 6y plus 6y plus 4. We're going to put into our groupings. We get 3y, which is 3y plus 2. And then we're going to take out a 2 and get 3y plus 2. So we get 3y plus 2 and 3y plus 2. And we have 2 of them, so we could write it as 3y plus 2 squared. So here we proved it, that it works. Okay. All right, question 9. So again, remember, we want to pull out our GCF if we can see it. In this case, the GCF again is -1. So we'll pull a -1 out and we get 25x squared minus 30x plus, nope, minus 16. There's a couple of things that prevent us from using or classifying this as a perfect square trinomial, and that would be that we cannot have a negative under the square root yet. That will probably be coming in either chapter 6 or chapter 7. And the other thing is that when we check the 2x times y, it would be 2 times 5x times 4, which would give us a 40x, which is not equal to 30x. Okay, so we got to just stick with what we know here. So we're going to take 25 times 16. And that's 400. We need factors of 400. That will give us a difference of 30. I'm just going to tell you that that's 10 and 40. So we'll do 25x squared minus 40x plus 10x minus 16. We're going to factor by grouping. So negative still outside, 5x would be 5x minus 8. I'm going to pull out a 2, 5x minus 8. So our answer here is 5x plus 2 and 5x minus 8 because they match with the negative outside. Again, you might not remember to have the negative outside, and that's okay. You're still going to be factoring, so I am fine with that. Right? Okay. Next up is another example where we have perfect squares. So we want to do 81x squared is going to be 9x. And then we'll check 49 y squared. Again, in your calculators, please do not put in the variables. That will mess up your calculator. Just know how to find them. You can put the numbers in, just can't put the x's in. And then we have to check our 2x times y condition, which would be 2 times 9x times 7y. That will give us 2 times 63 xy, which is 126 xy. So it does work. Okay, so we can go straight to our parenthesis set. So it's going to be 9x. Remember, we want the middle term. So minus y, minus 7y. Okay. And that's it for that one. Okay, 11. 11 is a difference of cubes, and 12 is a sum of cubes. Pay attention on the test because I don't know if these two are flip-flopped. And this is the approach we want to take. We want to find our x, which in this case is the cubed root of 27a cubed. I'm going to do this one at the same time because they happen to be the same, just with a different variable. The cubed root of 27 is 3, so we'll have 3a. On the other side, we'll have 3c. If we want to find x squared, which we will, we take 3a squared, which is going to be 9a squared. And then same thing on this side. Okay. And then we also have y, which is the cubed root of 64b cubed. Again, do not put your letters into the calculator. So that will give us a 4b. So y squared will be 4b squared, which is 16b squared. Your y over here is the cubed root of 1,000, which would be 10. So then y squared is equal to 10. And then we also need xy. Remember, in this case, it's just xy. So 3x times 4b equals 12. Oh, sorry, not x. This is a. So 12ab. Xy here is 3c times 10, so 30. 30c. And then now we just have to plug it in. So remember, it comes straight from the sign. So x minus y. Then we'll have x squared. Change the first sign to a plus. Xy, always positive. Okay. If you say that to yourself every time, you're going to get it. So here we just literally fill them in. X, y, x squared, xy, y squared. Okay. So 3a minus 4b, 9a squared plus 12ab plus 16b squared. That's it. That's all she wrote for that one. Okay. Same thing here. Again, you're going to look at your term. So it's going to be x plus y first, then x squared. Change the sign back to y squared. So we plug in 3c plus 10, 9c squared minus 30c plus 100. Excellent. Okay. All right, we just have to do 12 and 13 and 14. And then that skips us to the harder stuff. Okay. right, so 12 is, or sorry, 13 is considered a difference of squares. Okay, you can check this by finding the square root of 121, c squared, which is 11c. And then you can check 256. You can see there's a difference. That's going to be 16. So the way we do this, because there is no middle term, we have to have one parenthesis set have our plus and one have our minus. So it'll be the x's, or the c's rather. And then 116 and 116. Okay. And if you FOILed that and went backwards, you would end up back at where we were at. Okay. For this one, we want to pull out a GCF first. That GCF is 6. That is going to leave us with 6 on the outside, c cubed minus c squared s squared. And we're going to factor these by grouping, plus 7cs minus 7s cubed. We are going to pull out a c squared, which will leave me with c minus s squared. And then we're going to pull out a 7s, which will be c minus s squared. Okay, we have our matching parenthesis sets. They are not a difference of squares, so we cannot continue. Okay, make sure you're always looking to see if you can continue, because you want to factor completely. All right, we've already done this slide. Okay, this is our first hard problem. Since I'm kind of showing you the order in which I would take the test, I would leave this one for a moment. Let's do this one. This is really close to 20. This one is, I thought this was a good one for 20. It still kind of is in terms of ideas. So, but we'll leave this one for last because it doesn't really match it quite as well. So our GCF here, take a look. We have the same squared binomial, all 3 places. So it's going to be y plus z squared on the outside. That's our GCF. And then what we have left here is y squared minus yz minus 20z squared. So we need factors of 20 that will have a difference of 1. And that's going to be 4 and 5. So it's going to be y squared minus 5yz plus 4yz minus 20z squared. We're going to go straight into factoring by grouping. So y plus z quantity squared. We're going to pull out a y. We're going to be left with y minus 5z. We're going to pull out a 4z and be left with y minus 5z. So your final answer is y plus z squared, y plus 4z, y minus 5z. Okay, that is your answer there. All right, again, very, 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 very close. That's not a word. Okay, and we'll skip that 20 for now. Let's come to 19. So the area of a rectangle is 40 inches, and we want to find the length and width of the rectangle, and we're given that here. So area equals length times width, but we're gonna write it the opposite way. sorry, length times width. Oh no. Hey, 1 second, guys. I have to reshare. Almost done. Almost done. So again, area, so then that'll be x plus 7 times 2x plus 3 equal to 40. And then eventually we'll move the 40 over. So that'll be, remember we want to do first outer oops, I messed it up, inner and last. So sometimes you get it right with the drawing, sometimes you don't. Anyway, we're gonna have 2x squared plus 14x plus 3x plus 21 equal to 40. We're subtracting 40. Also going to add these together. So 2x squared plus 17x minus 19 equals 0. And now remember, your process is to take 2 times 19. And that's going to get us, let me find my written problem. Here it is, 38. Surprisingly, the factors we need are in fact 2 and 19. So we're going to do 2x squared minus 2x plus 19x minus 19 equal to 0. We're going to go straight to factoring. We're going to factor out a 2x and have x minus 1 left. And then we're going to pull out a 19 and have x minus 1 left. We're going to set these equal to 0. And what we end up seeing is that one of our solutions is equal to a negative number. That's a negative fraction. So we actually ignore so we only go with the positive for distance, dimensions, that kind of things. Okay, so what we're going to do now is we're going to plug in our x equals 1 for our length, which would be x plus 7 equals 1 plus 7. So length is equal to 8 inches. And width would be 2x plus 3, which is 2 times 1 plus 3, 2 plus 3. So width is equal to 5 inches. And you can check that literally because we know that 5 times 8 would give us the 40. So one more problem before we go over 19, and that is 21. Yes. Okay, so this one's kind of difficult. I think 19 is a little bit harder, so, and 18 is the hardest for sure. So we're going to pull out a 4z squared. Okay, and that is going to leave you with a 4z squared on the outside, a 10z to the 6th on the inside, because remember we add exponents, a minus 7x, or sorry, z cubed. Oh no. Can you go away? Can you go away? Can you go away? Maybe if you erase everything, you'll go away. You're not gonna go away? Cool. Guess that's how it worked. So GCF again is 4z squared. We're going to pull that outside. We're going to have left 10z to the 6th minus 7z cubed minus 12. We're going to take 10 times 12. It's 120. We need factors of 120 that are going to end up giving us, nope, that's not right. 5 and 24, 6 and 20, then 8 and 15. Okay, we want factors that will give us a 7. So 4z squared, 10z to the 6th, minus 15z cubed, plus 8z cubed, minus 12. So we get 4z squared, go straight to our parenthesis sets. We're going to pull a 5z cubed out. We're going to 2z cubed minus 3. One second, guys. Okay, so that's going to let us bring out a 4, which will leave us with a 2z cubed minus 3 again. So we have 4z squared, 5z cubed plus 4, and then 2z cubed minus 3. Okay. All right. Is this the last one? I'll do this one, which is the hard problem that's on the test for sure. And then I'll do the last optional 20 that I feel is good for you to know, but I don't feel like it's as good as the one that I gave you before. So, okay. Number 18, here we go. So the first thing you have to do is you have to recognize that this is in the form of a squared minus b squared. Okay, and we would normally split it up into a plus b and a minus b. However, the b squared in this case is its own trinomial. Okay, and it's actually a perfect square trinomial, which is really nice. So if we look at it over here, if we do n squared, and I believe we need to kind of change up the, nope, we're just gonna do it like this. Okay, so we pull this over, we do n squared plus 12n minus 36. And we're going to focus on the factors of 36. That would give us 12. Or we could check it. So the square root of n squared is n. Square root of 36 is 6. And then it would be 2x times y. 2 times n times 6 gives us 12n. So 12n matches. So we can actually go straight to m squared minus n minus 6 squared That's why the terms and the changing the signs important. So it has to be a negative, which means we needed to change our signs. Because again, remember, we can't have a square root of a negative there. It's just kind of hard to this problem. That's why I just don't like it that much, but unfortunately it's the best thing for your example. So you can check this, make sure it's right. So if we have negative out front, this is just to check this portion. Get first, which is n squared, outer, which is minus 6n, inner, which is minus 6n, and last, which is negative times a negative 36. So it'd be n squared minus 12n plus 36. Okay, do you guys, and now when we distribute, we get negative n squared plus 12n minus 36. That checks with right here. Okay, so let's finish out the problem. We're going to go straight to our parenthesis sets. We're going to split the m. Remember, we have a plus and a minus. This is coming back to this idea right here. And then we're going to do n minus 6 and n minus 6. And then we just have to simplify by distributing this negative. So we'll have m plus n minus 6, and we'll have m minus n plus 6. Okay. Highly, highly, highly recommend watching that part a few times. Not my favorite problem, like I said, but you do have to get tested on it. So the extra problem is this one. And remember, what we would do is we would say, let p plus 1 equal q, or literally any other letter but p. So we'll have 10q squared plus 29q plus 10. We need to do 10 times 10, which is 100. So we need factors of 100 that'll give us 29. That's going to be 4 and 25. So we're going to have 10q squared plus 25q plus 4q plus 10. Go straight into our factoring by grouping. We're going to pull out a 5q. And we're going to get 2q plus 5. And then we're going to pull out a 2. And we're going to get 2q plus 5 again. So we're going to get 5q plus 2. And we'll get 2q plus 5. Again, if you went through and foiled this, you would get back to here. Get back to here, but that's not the answer. So we have to take one more step. And we have to say 5, and q is not q, it's p plus 1. So 5 times p plus 1 plus 2. And then let's do 5, nope, 2, p plus 1 plus 5. And then we have to distribute and simplify. So we would end up with 5p plus 5 plus 2, and 2p plus 2 plus 5, which would leave me with 5p plus 7 and 2p plus 7. Okay, and that should check you back to here, kind of, because you would end up getting that full answer and this full answer when you work this out. So not the greatest internal check. It is why it's one of the harder problems. I will see everyone tomorrow in class for your exam. Remember, the exam has to be in person, and I will also add this and the video onto Canvas. All right, guys, study hard.